So in this video, I'm going to talk about using the subspace test, and all of my potential subspaces will be either from R3 or from some of the set of matrices. I'm going to go through these 5 examples using the subspace test, and I think it would be helpful just to remind ourselves what is that. So if W is a non-empty set of vectors in a vector space V, then W is a subspace of V if and only if the following holds. So these are the 2 things that we've really got to check. If U and V are in W, then U plus V has to be in W. And if K is a scalar and U is in W, then KU is in W. So the other thing that is something that you have to just be careful of is if it's not obvious, you do also have to prove that W is not empty. So just it kind of depends on what you're talking about. Sometimes this might be not obvious. I mean, I know to us it might seem obvious, but this is almost like a third invisible condition, I guess you could think of. Okay, so let's just jump into this. So the vector space is R3, so do all vectors of the form A22 form a subspace? So let's say that I take 2 vectors. So let's say I've got A22 and B22. So if I add those together, well, okay, so what operation do we actually use? Well, this comes from just R3, so we're assuming the normal operations in R3. So if I were to add these together, I would get A plus B, 2 plus 2, and 2 plus 2. So this is going to be A plus B and 4, 4. So remember, what this says is that, so if you have these 2 vectors in W, then U plus V has to also be in W. So notice what happened. I need vectors of only this form, and by adding these 2 vectors, now they are no longer in the desired form. So this would not be a subspace. So this is not a subspace of R3, not a subspace of R3. Okay, so moving on. So we're still in R3, so do all vectors of the form ABC, where C equals A minus B plus 1, form a subspace? Okay, so another way to visualize that would be A, B, and then I'm just going to rewrite C as A minus B plus 1. Okay, so this is the form that my vectors need to keep no matter what. So what I'm going to do is I'm going to take a first vector, U1, U2, so this will be U1 minus U2 plus 1, and then I will add to it a second vector, V1, V2, V1 minus 2 plus 1. So if I add these 2 together, so I'm still in R3, so I can just assume the normal operations from R3. So this will become U1 plus V1, U2 plus V2, and then if I add these together, I get U1 plus V1 minus U2 minus V2 plus 2. And you can see now, because I have this plus 2, that breaks the form that I needed. I need this to always be A plus 1. So by adding these together, I break the form. So this is not a subspace. It needs to have that plus 1 to be in form. Okay, so now we're going to move on to matrix subspaces, potential ones. So I've got the set of all n by n matrices. So do the set of all n by n matrices such that the determinant of A equals 0 form a subspace. Okay. So this is still going to be a no. So all you have to do for this one is find any example that would break it. So let's say that I have some matrix A of this form. So where I have maybe a row of zeros, and then the rest of this can be whatever. So I guess I'll call this a, let's see, let's call this A22, A2n, and I'll just go down to this way. So sorry, this should have been A21, sorry. And then this will be ANN. Okay, so here's my first matrix. So I have a 0 row here, and I'm going to add to it. So I'm going to have this B11 to B1n, and then in this row I'll have all my zeros. So I can see here that if I add these together, so this clearly has determinant 0, this clearly has determinant 0 because I've put in a row of zeros here and a row of zeros here. So because I now have B11 to B1n this is going to be A21, A2n, and then down here, oops, and these should have been B's. Okay, so now I'm going to have AN1 plus BN1, and then A and N plus B and N. So this now might not have a determinant equal to 0. So because of that, we have found that there is a potential to take two things that are in this set, and when you add them, they're no longer in the set. So this is also not a subspace. Okay, so now I need to know, so I still have n by n matrices. So if I have matrices such that A times B equals B times A for some fixed n by n matrix B, form a subspace. So what this means is that B, I always have to multiply everything by B. B is fixed, okay? So I can take matrices A and C in the subspace, and note, so AB will equal BC and, BA, and CB will equal BC. Okay, so let's see if I can get through these axioms. So far I have not been able to have a single subspace. So if I take A plus C and multiply it times B, so let's see, what am I going to get? So using what I know about matrices, this will be equal to AB plus CB. And now that I have these two, I know that I am allowed to reverse the order since I'm multiplying by B, so this will be equivalent. And if this is equivalent, I can effectively factor out the B to get this. So what I have here is that finally I have something that is closed under addition. Cool. So now let's check the other one. So I'm going to have K times, actually let's go KA times B. So this will be K times AB. I can multiply like this. Well, this will equal K times BA, right? Because AB equals BA. And so this will equal then, so this is really showing then that these are equal. So now using what I know about how scalars commute, I can rewrite this as B times KA. So you're allowed to multiply a scalar at any point in the process of multiplication. So I can move the scalar in here. So this does pass the subspace test. So yes, this is a subspace. Finally. All right, we got one. Okay, so for this last one, so I've still got the 2 by 2 matrices. So we're going to use matrices of the form AB 2, 2, AB in the first column. So if I just take two of these random matrices, so let's see, I'll take the first one and then I'll set up a second one. So this will be C2, D2. So if I add these together, so I'll see that I have A plus C, 4, B plus D, and 4. So now this no longer follows the form of this. So this is not a subspace. Okay, and so there are a handful of examples. So if that was helpful, I'd love it if you hit that like button. And otherwise, I will talk to you guys in another video. Talk to you later.